Sun is a middle-aged star. The Sun is about 4.6 billion years old and is roughly halfway through its lifespan. Scientists estimate it will continue shining for another 5 billion years before expanding into a red giant and eventually shedding its outer layers, leaving behind a dense core called a white dwarf. This timeline is calculated using nuclear fusion models and observations of similar stars. It's not actually yellow. The Sun emits light across all colors, making it white. However, Earth's atmosphere scatters blue light, making the Sun appear yellow during the day and red-orange at sunrise or sunset. This phenomenon, called Rayleigh scattering, was first explained by physicist Lord Rayleigh in the 19th century. The Sun's core is a nuclear powerhouse. Deep inside the Sun's core, temperatures reach 15 million degrees Celsius, and pressures are 340 billion times Earth's atmospheric pressure. These extreme conditions fuse hydrogen atoms into helium, releasing energy equivalent to 100 billion nuclear bombs exploding every second. This process, called nuclear fusion, powers the Sun and sustains life on Earth. Sunlight takes thousands of years to escape. Photons, light particles born in the Sun's core, take tens of thousands to millions of years to reach its surface due to constant collisions with plasma. Once they escape, they travel to Earth in just 8 minutes and 20 seconds. This light travel time was confirmed through helioseismology studying solar vibrations. The Sun has weather. The Sun experiences storms, winds, and rain. Solar flares, explosive bursts of energy, and coronal mass ejections, massive clouds of charged particles, can disrupt satellites and power grids on Earth. In 1859, the Carrington event, the largest recorded solar storm, caused telegraph systems to spark and auroras visible near the equator. It sings. The Sun vibrates like a giant bell due to pressure waves generated by turbulent plasma near its surface. These vibrations, studied through helioseismology, create a solar hum that scientists convert into sound waves. The European Space Agency's Solar and Heliospheric Observatory SOHO has recorded these eerie, musical tones. The Sun's outer atmosphere is hotter than its surface. The Sun's visible surface photosphere is about 5,500 degrees Celsius, but its outer atmosphere corona heats up to 1 million degrees Celsius or more. This paradox, called the coronal heating problem, remains unsolved, though theories suggest magnetic waves or nanoflares might be responsible. Solar tornadoes larger than Earth. Magnetic fields on the Sun can twist plasma into colossal tornado-like structures. Some span 120,000 kilometers, 10 times Earth's diameter, and spin at speeds over 300,000 kilometers per hour. NASA's Solar Dynamics Observatory captured these phenomena in 2012. The Sun loses weight every second. Through nuclear fusion, the Sun converts 4 million tons of mass into energy every second as per Einstein's equation E = mc². Despite this, it's so massive that it will take billions of years to lose even 1% of its total mass. It's not a perfect sphere. Due to its rotation, the Sun bulges slightly at the equator and flattens at the poles. This oblateness was measured by NASA's Solar Dynamics Observatory in 2012, revealing the Sun's equatorial diameter is about 10 kilometers wider than its polar diameter. The Sun's magnetic field flips regularly. Every 11 years, the Sun's magnetic field reverses polarity. This cycle drives sunspot activity and solar storms. During solar maximum, sunspots and flares peak, while solar minimum brings calmer conditions. The next reversal is predicted around 2025. Solar wind creates a protective bubble. The Sun constantly emits a stream of charged particles called the solar wind, which travels at 1.6 million kilometers per hour. This wind carves a protective bubble around the solar system, the heliosphere, shielding planets from harmful cosmic rays. NASA's Voyager probes crossed the heliosphere's boundary in 2012. Ancient civilizations worshipped the Sun. From Egypt's Ra to the Aztec's Tonatiuh, nearly every culture revered the Sun. Modern science continues this fascination. Missions like the Parker Solar Probe launched in 2018 are touching the Sun to study its atmosphere. The Sun moves through the galaxy. The Sun orbits the Milky Way's center at 720,000 kilometers per hour, completing one galactic lap every 230 million years. It also bobs up and down through the galaxy's disk, influenced by gravitational interactions with stars and dark matter. Solar eclipses are cosmic coincidences. The Moon is 400 times smaller than the Sun but also 400 times closer to Earth, making them appear the same size in our sky. This perfect alignment allows total solar eclipses, which will end in about 600 million years as the Moon slowly drifts away from Earth. The Sun's energy fuels almost all life on Earth. Through photosynthesis, plants convert sunlight into chemical energy, forming the base of Earth's food chain. Even fossil fuels like coal and oil are stored solar energy from ancient plants. Researchers estimate 99.9% of Earth's ecosystems rely directly or indirectly on the Sun. The Sun has a twin maybe. Some astronomers hypothesize the Sun was born in a star cluster with thousands of siblings. A potential solar sibling, HD 162,826, was identified in 2014 using chemical composition and orbital data. Finding more could reveal clues about the Sun's origins. It's a medium-sized star. The Sun is classified as a G-type main sequence star G dwarf. While it's larger than 90% of stars in the Milky Way, it's dwarfed by giants like Uae-Scuti, which is 1,700 times wider. This mediocrity makes it stable enough to support life. The Sun's light sparkles on other worlds. Sunlight reflects off planets and moons in our solar system. For example, Saturn's moon Enceladus reflects so much sunlight it's one of the brightest objects in the solar system. The New Horizons probe even captured sunlight glinting off Pluto's mountains in 2015. We're all made of stardust, including the Sun. The Sun and planets formed from a cloud of gas and dust enriched by debris from ancient stars. Elements like carbon, oxygen, and iron in our bodies were forged in stellar explosions long before the Sun existed. This connection was confirmed by spectroscopy and meteorite analysis. The Sun's gravity bends light. Albert Einstein's theory of general relativity was proven in 1919 when astronomers observed starlight bending around the Sun during a solar eclipse. This phenomenon, called gravitational lensing, shows how massive objects warp space-time. Solar storms can create auroras on other planets. Jupiter and Saturn experience auroras far more powerful than Earth's. NASA's Hubble Space Telescope and Juno spacecraft have observed these light shows, triggered by solar wind interacting with the planet's magnetic fields. The Sun's rotation speeds up its equator. The Sun rotates faster at its equator about 25 Earth days than at its poles about 35 Earth days. This differential rotation twists magnetic fields, creating sunspots and solar storms. The phenomenon was first documented by Galileo in the 1600s. It's getting brighter over time. As the Sun ages, its core becomes denser, increasing fusion rates and brightness. Models predict the Sun will grow 10% brighter over the next 1 billion years, eventually making Earth too hot for liquid water. The Sun's sneeze could wipe out technology. An extreme solar storm could disable satellites, power grids, and communication systems. Governments now have space weather action plans, and scientists use satellites like NOAA's SCAVAIR to monitor solar activity. Final thought. The Sun is not just a fiery ball in the sky, it's a dynamic, complex engine that shapes life on Earth and the entire solar system. From its musical vibrations to its role in ancient myths, it continues to inspire awe and curiosity. As astrophysicist Carl Sagan said, "We are star stuff harvesting sunlight."